So let's look at the files and processes. So as I mentioned before, the third part of the operating system is programs. So basically programs are nothing but files or a process. So everything in Unix is either a file or a process. And a process is basically a program that is executing, and it is identified by unique PID or a process identifier number. So any process that is running or any task that is running on your operating system has a unique process ID. And this is not just true for Unix, it's also true for Linux. So Linux and Windows. So if you're working on Windows, you must be familiar with Task Manager. So Task Manager is basically, it's a manager that shows you all the tasks. And as you can see, these are basically programs that are running. And if you go to the View tab and enable this PID, then it will show you the PID numbers of the processes that are running. So this is same for Linux or Unix systems as well. And basically, these processes have this unique identifier by which you can identify them. So on Linux, to look into the processes, you give a top command or a htop command. It's the same. And this is basically the task manager or a process viewer for a Linux type operating system. As you can see, the first column is a PID. This is the process identifier. And the second one is the user that is running it. Then you have the virtual memory, the CPU, the amount of CPU it is using, the memory usage, and the time for which it is running. On the right, this is basically the path of the executable binary, or the file that is getting executed. So it is very similar to what you are used to in Windows type environment. So now that we have understood what a process is, let's look at what a file is. File is basically a collection of data. And as you understand, each process is basically a file. It's just that the file is being executed by the OS, and that's why we call that a process. So a file can be of different types. A file can be a document. It can be a text of a program written, like for example, a file written in C is also it's a collection of data. Um Same thing for a Python script. So it's basically a text of a program. A file can be a binary or executable binary file. Like for example, when we executed the command like ls is basically a binary file. So it's an executable file which you can execute. A text file you cannot execute because it's a text. It is not in the OS readable format. Any OS readable format, we call it a binary file or an executive file. In Windows environment, the executables end with an exe extension. Say for example, here we have this mysql.exe. So this is an executable file. And if you go to that file location, so as you can see here, these are all executable files and that you can run on the kernel. The third type of file, which we call a directory, basically, this is a container or a collection of directories or files. Um, and this is similar for all operating systems. If you look at Windows, say if I go to C drive, then you have this program data or program files. This is basically a directory which contains other directories or files. So in this case, you have this one file, desktop ini. This is a file, but the remaining, the other things, these are directories. So directory is basically a container, but on a broader sense, you can say it's a file. So let's look at directory structure. So what is a directory structure? This is basically a hierarchy in which, or a format in which your file system is arranged. And in any operating system, you will have directories and subdirectories. And like I showed you in a Windows-like operating system, you have what we call folders, and inside the folders you have directories. Like for example, in GNU32, this is a directory. If you go inside, there is a subdirectory, and inside that there is other directories and then files. And this is the hierarchy. It's like a tree structure, and it is a way to organize your files and folders. So in this case, in this example, this is a tree, this is a user directory, and it has a bunch of subdirectories. Say for example that ee51ab, this has a file called project.txt, and then it has a subdirectory called Unix stuff. In a Windows environment, you can open up Explorer to explore through your directories and subdirectories. Same for Linux. If you have a Linux desktop, then you have a window, and in the window you can navigate through your directories and subdirectories. In a shell environment, however, in order to navigate or list the directory structure, you can fire a ls command. The ls command tells you um, what are the subdirectories and the files that are contained in your current directory. So if I go to home and you fire an ls command, so you see these color coded in blue, these are directories, and the ones in white, these are subdirectories. If you want to view the directories as a tree, then you can fire up a tree command. Of course, this is not available in all operating system. You might have to install this package called tree, and then you do an l is basically a level. I want to see two levels, and say I want to look into this users folder, so I will put in the users. So what it shows me is it shows two levels of directories and subdirectories inside the users folder. So this is the users folder. It has a subfolder called crazy coder and then subdirectories, and it also has files like readme and then toshib.md. And then there is another subdirectory which is in parallel to the crazy coder directory. So there basically users has three of these directories, and in this subdirectory there are two more directories which is called project 3 and project. So this is a way to visually see the tree structure of a directory in a shell. So you can always change it into three levels, and I think your screen will get or filled in. So no, hopefully it did not. So as you can see the all the trees of the directories and subdirectories and files in that users folder. Okay, let's come back. So starting an xterminal session, this is basically xterminal is basically the shell. So you can start it by clicking on the shell icon if you are using a Linux type environment or a Unix type environment. And if you're using a Windows environment, then you use the POTI tool to SSH into a remote server or remote shell. That's what I'm doing here. And once you fire up the terminal, you get something called a window or a black box, and there will be a prompt which will be either a percentage or a dollar. In a Unix environment, it shows up as a percentage, and in a Linux environment, it shows up as a dollar. Of course, it depends on the shell you are using. And what it means is that you are not ready to fire in a command or type in a command. So you will have the cursor just after the dollar sign where you can type in all the commands that you want. Let's look at um, some types of the shell. So Unix shell, though we call it the shell, but shell also has different types of shell. These are the list of some commonly used shell, like the Bourne shell. This is one of the oldest shell, and it's also denoted by sh. And then you have C shell, TC shell, Corn shell, and then Bourne again shell, which is called bash, and then Z shell, which is called ZSH. So we will be basically using these two shells because these are the more advanced ones, and it has a lot of features. The Z shell has a little bit of support for graphically choosing directories, subdirectories, file completions. So all those goodies are there in the Z shell. But by default, most of the Linux distros that come are packaged with the bash shell. So an easy way to check which shell you are using is to fire up the echo command. So I will fire up the echo command, and you can see that this is a bash shell. To move between shells, so what you can do is first check in which shells are there, like cat etc shells. This gives you a list of shells that are installed in your system. So you can see I have sh, zsh, and you can use any of these shells you want.